Very good afternoon to all. Today I am going to present my topic of industrial automations and introductions. Before I am to start my topic, I have to introduce about myself. I am Dr. P K Manikandapirabu, Associate Professor, Department of Mechanical and Automation Engineering. I am working now in PSN College of Engineering and Technology. Previously, I did my engineering in Mepcos Engineering College in 2005. After that, I did my M.Tech in PSG College of Technology, Coimbatore. Then I have started my PhD in Dayananda Sagar College of Engineering, Bangalore. From I started my career in PhD work. I did finished my PhD in 2018 in Visvesvaraya Technology University, Karnataka, into the topic of online instability studies and control in ducted axial flow fan. This is my introduction. Previously, I am having 12.5 years experience in my teaching career. Now, we will start my video lecturing of topic of industrial automations and robotics. Now, we are going for automations because every day in manufacturing sector is producing a lot of machines and components, so we need lot of accuracy and production rate and quality and total quality everything is needed in the final semester students. Very important subject is industrial automations and robotics. Nowadays trend is going on in automation side. Automation in advanced stage. So industrial automations and robotics is a new subject. It's a one of the wonderful subject for our mechanical engineering students. Now we have to start with the topic introductions. Introduction: automation is encompassing virtually every walk of life. Every human walk of life is automation is encompassing virtually. Because automatic solutions are required right from from space, agricultural to space technology, automation solutions is all the places is very much required and essential. Now, the plant automations, because plant automation is a important key things in a necessary for manufacturing industrial sector to survive the today's global competitive market, because surviving the fitness is the term of quality. Now, robotics and industrial automation refers to the use of control systems, and using by computers and information technology in handling various processes and machinery in an industry. We are studying the ultimate. We have to reduce the labors. We have to reduce the interference of humans. We have to reduce the work from humans. Only by using machines through robots or natural artificial intelligence robots and another machines, man-made machines only have to work out and reduce the human work. That is the ultimate aim of industrial automation subject. In the robotics and automation is refers to the use of control system and computer and information technology (IT) subject in handling various processes and machineries in an industry. The ultimate aim is to replace the manual labor and increase the efficiency, speed and overall performance of the system, because this is our ultimate aim, none other than that. We are using human being without avoiding the human work, but using human brain to make them to control by using the sense of industrial means we have to work for natural experimental work or ordinary work. Comparing industrial work means the people is worked with for the particular work to make a product to get a benefit by society. In this we are avoiding human work using computers and using control processing unit, and using PLC. Another advanced concepts used and avoid the human work and using by computer brain to through the control logics to make a perfect system by using automations. This area to cover more advanced courses would also be taken on the following specializations because is the industrial automations and robotics. The major lot of the topics is to be covered because artificial intelligence is one of the ultimate subject useful for this IAR. At the same time, we are going for automations. Manufacturing also is very essential one because through the usage of computer by using manufacturing came computer aided manufacturing subject is one of the important subject to learn the skill, acquire the skills. And the same thing computer aided manufacturing and computer integrated manufacturing systems. Computer integrated manufacturing systems and robot motions. Robot motions planning. How to control the planning because we are not able to not only study the robots because IAR subject is fully engaged with the 5 units. First unit is pure automations. What is automations? What are things involved in automations? In the second unit is covered with manufacturing automations. What are the advanced concepts used in this manufacturing? How to reduce the human interference. And third unit is robotics, basics principles of robotics. And fourth unit is using exponential components, essential components and drives, either robotic drives and motions control. And fifth unit is covered with belongs to the fifth unit programming, robot programming. So these are the 5 units involved in industrial automations and robotics. Opportunities. These are the opportunities involved for robotics. The creation of automation system, robotics maintenance, intelligence automations. In automation is a subject. In this, we are using the intelligence C. And now already everyone know in BE, artificial intelligence and machine learning. This is a new concept. Is adopted for the new trends setter for future scenario, machine learning and artificial learning. These are things, new things for opportunities in the world wide. New engineering avatar that make that the creation of automation systems and robotics maintenance and intelligence automations and machine learning and artificial learning are the main areas of employment for robotics and industrial automation systems. These are things involved. Now, how you define automations? Automation is a process that uses softwares, machines and other technology to carry out some task in place of human workers. Automation is a process that uses the software, machines and technology to carry out some task or particular work in place of human workers. No need to do any human interference. Automation is applied both virtual task and physical ones. Automation is applied both virtual task and physical ones. This methodology can be used for many simple functions such as programmable thermostat and by using elevators and lift going from when you are going the elevator from down first floor to second floor or second floor to third floor, any one task to complete by using automations, you would write a lot of programmings. It can also perform extremely complex process such as in manufacturing and is sometimes powered by artificial intelligence of machine learning. So automation is a process that uses the software, machines and other technology to carry out some task in place of human workers, and automation is applied to both physical task and virtual task also. This methodology applied is by using lot of various programs. It's enabled to make them to run the system. Whatever the mechanical code is there and programming code is there, make them to enable to complete the task. Whatever sensor sends the signal to make them to activate the process and run the system. This is a very important essential thing to make to enable the automations. It can also perform the extremely complex process such as in manufacturing, sometimes powered by AI and AI tools and machine learning tools also we can use. And robotics. Robotics, everyone know. Robotics is a field of combines engineering and computer science to design and build robots to perform some small tasks. Robots, they are creating making a lot of categories. 3 categories is given. Entirely human robot, human input to operate, and semi-automatic robots. They can perform some task on their own, but human intervention and observations that should be there. So, if you do the low-cost automations, small do the normal work, and then do low-cost automations, and semi-autonomous robots and complete autonomous robots. Like 3 things have to involve. Semi-autonomous robots can perform some tasks and human intelligence also is there. And autonomous robots completely do the intelligence of programming. To perform the task entirely such a own things. The program only do the task. No human interference and interference. And it can't respond to real world environments with minimum human interference only. The 3 things. So, semi-autonomous robot, autonomous robots. Now, discuss about the topic of artificial intelligence. Artificial intelligence already they have developed from our Dartmouth University. Marvin Minsky has made a tool in 1956. Herbert Simon also is used. Intelligence in machines. So, in this internal machines, internal models of the world search through the possible solutions, plan to solve problems, symbolic representation of information, and hierarchical system and sequential program of executions. So, intelligence in machines, what the mode it's internally they are able to model the world system, it's able to make the model. How you have to get solutions? When you are searching, this is one of the keywords should be used. So what are the typing the word, how to solve the problem, what are the keywords you be used, that is also one of the solutions. And so how to solve, you have to make your algorithm, so you have to able to solve the problem. You have to make the algorithm in a neat clear mode to solve some problem. Symbolic representation, this is a graphical chart is used to symbolic representation of the systems. This is a hierarchical way, top to low or lower to bottom. Like that, you have to make them to understand the system. That program should be sequential mode. This is the way to intelligence in machines. This is history of automations. Actually, normally we have done previously manual control. Next, we are doing partial automations and then complete automations. In this manual control mode, next we have done with next generation is pneumatic control. The pneumatic control in this first manual control, mechanical control, mechanical, electrical, electronics control. Then we have to use the system of in mechanics, pneumatic and hydraulics. That hydraulic systems able to control the automations. Then we have slowly add the hardwire logic control, hardwire logics controls and electronic control. In this electronic control is advanced the techniques used in the theory. Electronic controls using gates or PLC that we have used. Then finally complete now the trend is going on in PLC, programmable logic controller. Programmable logic controller, that the things has to be used. These are the automations. What are the steps of automations? automations, office, what are the types? Building automations, the buildings making by through the man as well as machines by the code, they are making them able to make them to generate the building by using lift and smoke detector and use the building automations. Then this next setup is office automations. Office automation system is to be set in the by using printers and CCTV cameras. By using printer and CCTV cameras, we can use the control the office. But this should be happen. Enterprise system and execution in office level should be monitored by using supervisory control. Make them using office automations by using CCTV cameras. In scientific automations, when we need to able to scientific automation in advanced concept is easily available in our ISRO, Indian Space Research Organization. So, and the same thing DRDO, Defense Research Development Organization, DRDO in ISRO, and the same thing NAL, National Aerospace Laboratory, and the same thing available in Bell also, Bell Bharat Heavy Electrical Limited. These are the advanced places. Rocket launching, at the same time meteorological weather report. Today is able to heavy rain, so monitoring system is very important. In rocket launching, fully automation only, not only partial automation or manual control, no manual control, no partial automation, completely automatic control of rocket launching is able to do in ISRO. And same thing NASA also. NASA also is one of the important rocket launching and missile launching. What are things should be happen? Same thing in application in all the areas. Light automations, like street solar lighting. Same thing as well as industrial automations. Industrial automations we are doing in automated bottle filling stations and steel factories, etc. These are the things involved in building automations and office automations, scientific automations, light automations, and industrial automations. These are the levels. Well, how we do that? This is the architecture of the systems also. From device level, machines level, system level, plant level, enterprise level. Device level we can use sensor, actuator, and other hard elements. In machines level we can use individual small machines. Cell level we can use manufacturing system groups and machines. And plant level we can use the production systems. And enterprise level we can use corporate information systems. These are the things. In system level, sensors, machines level we can use advanced unit level operations we can do, and cell and system level various plants are used to use the systems, and the same thing like manufacturing system group of machines and individual machines and production system, various plants and enterprise systems, corporate information system in like overall methodology of the total company, enterprise systems. Like device systems we can use actuators and sensors and hardware to form an individual control loops from next level. And machine level we can use CNC machine tools and production equipments and industrial robots and material handling equipments. And cell level manufacturing cell or system. Plant level factory or production system level. And enterprise level corporate information system. These are the various level of automations. In enterprise level we can use in the PC and servers we can use. Plant level personal computer we can use, and cell also we can use the personal computers, and machines level we can use program logic controls, and sensor level we can use the FPGA systems or sensor system we can be able to use. These are the type of automations. Type of automation is one of the type is software automation. You can write the code by using software. You can be able to do the small work complete by using automation by small sample or simple program by using computers to carry out the repetitive tasks. In a virtual environment, we can do the repetitive, means continuously we have to do the experiments, continuously do the task. For that we can use software automations. Like example, the bottles, pots, or it's not a physical robots that can use the automatic tasks such as auto filling forms or financial service we can able to do in this software automations. Next one, next level, robotic process automations. Robotic process automations is a software automation design the computer user interface same a human worker would. Some RP tools enhance the machine learning and AI help to perform such tasks. Some it is efficiently you can do it. The robotic process automation is a type of software automations designed to use of the computer user interface. To use the computer user interface the same way human worker would. We can able to do. Some RP tools are enhanced machine learning. We can robotics process automations. We can using AI concepts also, machine learning concepts also to perform the rules to efficiently do the lot of tasks with efficient way. Can able to do it. And last automation is industrial automations. Here what we can introduce machines to control the systems and physical process. Common example is CNC machines, automated inspection equipments. It is include robot automations. So industrial automation is nothing but machines to be able to control the physical process. Common example is CNC machines. And other extraordinary sophisticated equipment means automatic inspection equipments. Now we are industrial automation, we are including the robotic automation program also. These are the historical developments. How is made? Is a sensor in our industrial automation. Sensor is our eye of our human body. Automation is a arm of the human body. How eye, our arm is important. Same thing in industrial automations is our sensor and actuators. It is very important for sensor and actuators. Is very important for industrial automations. Like our human eye and human arm. It's nothing picturized is shown in the monkey and the elephant and fly and any bird such as flying and taking the fish and like arm how will be involved to rotate. The degree of freedom is a feel the greatest invention of mankind could have been something else. Our imaginations are blocked by the symmetry of the wheel. That's a bad woman knows whom that is on the invent the wheel that became the first ever road traffic accident is a statistic. First action is made because of human error. So to avoid the accident, we are going for the automations. And managerial the team, how to develop the historical development, how to the contribution of managerial and technological growth. They have explained in the concepts of mass productions through transfer line and line balancing. The Henry Ford developed the assembly lines for mass production automobiles of the popular mode T. Such a standardization used to say that choose any color you want as long as it's black. Three things is involved: plant layout and transfer line. Make them to line balancing. Plant layout to make the workspace layout to minimize the movement of men and tools, man, materials and methods. Same man, tool and pods to minimize the movements in the space layout. According to that, you have to make plant layout. Same thing, you have to use slide or ramp or some other thing to form as a conveyor for moving the pods wherever as possible. He used gravity to assist such movements. Using slide assembly lines by which pods to be assembled or delivered a convenient interval space, make them to work. These are called transfer lines. This also introduces the concept of line balancing. So things is important is line balancing as a plant layout and gravity and transfer line. These are things important. According to the line, it's a place itself. Assembling and deliver conveniently we have to make. According to that, you have to work to reduce the movement of work. Making out the workspace we have to make to minimize the movement of man tool parts. This is a very important thing now in plant layout design, because finally the only automation is not come to enable the all the engineering things, all the industrial concepts from mathematics to final design, everything, all subjects should cover, then only automation is neatly adapted and make them to complete automation is possible. So for that we need design information also, manufacturing information also you to make them to understand, then only get a better output. In this design output, design information, first you have to understand the geometry thing, whatever the making a product, first you have to need the geometry, then fits, in that their tolerance level, what are the materials used for this making of design and manufacturing a product, what are the materials should be used and their specifications and codes and standards. First after that, when you understand the things, initial data you have to return, then you have to make CAD models. Not only CAD models, should not be able to make them the assembly thing, assembly drawing. Then with respect to the tolerance level, material specifications, code, fits and tolerance, geometry, everything you have to include in that drawings. These are the things involved in design informations. Next, you should cover manufacturing informations. In this manufacturing informations, you have to start the sequence of different process involved, sequence of process and sequence of operations or steps in which each process should be covered. Then description of each operations and tooling of each operations like machines tools and work holding devices and cutting tool and press tools, etc. and motions and switching and toggle functions and setup time and unit time for each operations. Because first you have to understand the design codes and design informations, and then next things we have to study to cover the manufacturing informations like sequence of different process, because we have to start from the raw material to finished product, how many process to be completed, which is the minimum process to reach the better quality and minimum time to produce the component. So sequence of different process involved and sequence of operations and steps of each process, and what are the description of process and what are the tools is necessary to use and what are the work holding devices and machine holding devices and what are the motions and motion study, ergonomics. Also we read the motion study, also important for the functions and setup time, unit time for each operation you have to include in the design and manufacturing informations. Then we are going for the manufacturing automations. Manufacturing automation is a second unit. First unit already completed. What are the things involved? Now we are going for manufacturing automations. Manufacturing automations includes the advanced technology, including robotics, and there in this visions and software installations and streamline to optimize the, why we are going for study the manufacturing automations, to make the optimize the production process, to complete the minimum process to achieve maximum time to minimum process and a good product, good component with no defects. This is our ultimate aim. Quality point is very good, ensure with quality. Manufacturing automations can take many forms, such as using autonomous robots to handle parts and products in strategic areas. It can also include the AI tools and high-speed cameras. High-speed camera also to monitor and capture the photos in the any error in the products. And in many manufacturing companies will invest at least one form of automations, from single robot to fully automated production line. Any one complete form of automations is very important by using robotic automation also, manufacturing automation also. Classification of automation already given, mentioned. Fixed automations, programmable automations and flexible automations. Fixed automations only hardware, Programmable automations only software. Flexible automations hardware and software combined. This is the classification of manufacturing automations. Classification of manufacturing automations in two types. One is hard automations and another one is soft automations. A hard automation in the sense mechanical automations and in the sense programmable automations. This is rigid and this is flexible. Now, what is the example of the manufacturing automations? Here, copy milling machines, automats and special purpose machines. Here, soft machines, PLC, NC, CNC, DNC, robots, AGV, reconfigurable conveyors. These are the things involved in the hard automations. This is soft automations. Mechanized automations and manufacturing assembly lines. The mechanization of parts, manufacturing of assembly lines. Mechanism means replaced human muscle power. Wherever economically possible, we have to reduce the human interference. Initially, water mill, wind mill, pneumatic, hydraulic, electric, everything implying in the advancements of automations, mechanical automations. In the sense, hard automations, now in the lathe also advanced machines, upcoming days, it's came our global market. Automats, copying machines, special purpose machines, and transfer lines, etc. All these things involved in hard automations. And flexible automations, numerical control, direct numerical control, computer numerical control, direct numerical control to programmable logic controller. These are introduced from 1960s. Soon now robots are developed. They were introduced for material handling, manufacturing automation also, material handling also, and assembly also. In optimal collection of CNC machines and robots is called flexible manufacturing systems. Here things involved in automations, downstream, upstream functions to the hardware production functions were integrated with computers, networks, communication protocols, SIM, everything involved. Computers, networks, communication protocols and SIM. These are the things involved and the complete automation package is covered. These are things, function and hard automation and soft automations. We are using the tools and templates and masters. Here softwares, the preparatory functions, G codes and M codes are used. Here the domain is binary domain or discrete domain they are asked. In the automation sense they are using trip dog setting and classes are also available because normally G code or M code they are using in soft automations and hard automations they are using CAM, templates and master tools are used. Here they are given the three things, fixed automations and programmable automations and flexible automations. In these three things, what are the things to be covered, what is the advantage and disadvantages of automations. Here fixed automations they are making the high demand volume and long product life cycles. Making the fixed automation, it's make high demand volume. And the advantages is maximum efficiency and low unit cost. And disadvantages is large initial investment and inflexibility. It's making in fixed automations. In their programmable automations, three things involved. One is programmable automation is used in batch productions. Advantages is very flexibility to deal the changes in the product. At the same time, it produces low unit cost for large batches. Here disadvantages. Here, new product requires a long setup time and high unit cost relative to fixed automations. In the same sense, the flexible automations is low production rate, is varying the demand, short product life cycles. Here, the advantages is low production cost. At the same time, flexible automation is flexibility to deal with various design variations and customized products. Here, disadvantages is larger initial investment. And high unit cost relative to fixed and programmable automations. These are things involved to consider for automations. In fixed automation, high demand volume, programmable automations used in batch productions and flexible automation used for low production rates. These are the productivity graphs. Here production variety versus volume is depicted as a picture, as a graph. Here low, medium, high is given in the y-axis and x-axis also low, medium, high is given. Here the operations involved for manual operations and fixed automations. Production volume is less means we can go for manual operations. Production volume will be high means we are going for fixed automations. At the same time, product variety in the sense we are given low to medium tasks, we can able to expect the programmable automations. And medium to production volume is medium to high, in the sense we are going for flexible automations. In the sense of production volume is should be high, we are going for fixed automations. At the same time, with respect to the production volume low and product variety should be high, we are going for programmable automations. Same thing, we are going for the medium product variety and medium automations. Production volume we can able to flexible automations. At the same time, medium production volume should be high and product variety should be low means we are going for fixed automations. This is the graph is represented as a diagram. These are the tools. Now recent development tools used for automations. These are the because industrial automation system is another subject. Industrial automation system, we have to need the what are the syllabus of industrial automations, what are the advanced things used for automations. Then next topic is covered for the sensorics. Sensor, what are the various measurements things is involved and how should be able to control, write the control system for measurements and our measurement systems or control system, how we are able to control. These are things is a small units. Each unit, various, the whole term, pressure measurement, velocity measurement, flow measurement, force measurement, flow measurement and various temperature measurements, everything involved in sensorics. So sensorics, various about studying about the machines and sensor, various sensor how you use for automations. And third thing is control system, how we can able to use the by using computers, how to write the make them to using the control systems as well as measurement systems. We need to be able to concentrate. Then automations. Automation related things you can be able to identify the various tools. ANN. First one thing is ANN, artificial neural network. A total network is completely covered by the artificially by like neurons. It cover and complete make them to done the process by using automations. Next, distributed control systems. This is another major unit. Here they are using another one of the important layer, SCADA. SCADA is supervisory control and data processing system. PLC, programmable logic controller. In this interface, what should we do? We are using transferable buses. Or connecting the things, we have to transfer the data from sensor to plant, plant to machines, machine to programmable logic controller. You have to sense the data, sensor send the data to PLC by using through two buses, mode bus and another one is profit bus. Like data communication protocols used to be used. So these are the things involved for automation tools, artificial neural network and distribution control system and human machines interface. Human machines interface and supervisory control and data acquisition system, and another one of the tool is programmable logic controllers. These are the automation tools. Now we are going for the industrial automations. These are the setups involved. By using the computer, complete the manufacturing task. The use of computerized or any artificial robotic devices attached to complete the task, manufacturing task. Plant, instrumentation, in the sense control system, in this hardware control or software control is combined in the systems. In this control, how we can able to do? Cold water to hot water to cold water. Changing the thermostat control by using thermostat control. By using manual control, pneumatic control, hardware control, electronic control and PLC control. These are the things: hardware, manual control, pneumatic, hardware logic control, electronic control and PLC control. By using cold water is entered into the system and thermostat is connected, change the things, you will get the hot water and you get the hot water as output. Next topic is PLC. PLC is one of the tool for automations. PLC means nothing but programmable logic controller. Is an industrial computer used to monitor the inputs and depending upon their state to make the decisions based on its program or logic to control all or of the outputs to make automate the machines or process. PLC is nothing but industrial computer used to monitor the inputs and depending upon their states, it's able to take the machines on the system or off the system to make the using programming logics. It's able to on or off the output of the system to automate the machines or process of the systems. These are the major components of PLC. Here from sensor and input module, power supply, processor, programming device, output module to output. The input is there as a device, push button, contact, limit switches, etc. To output, solenoids, contactors, alarms, etc. they are given. The major component of PLC, power input is given, processor automatically do the work. We are using programming device to supply the program code and get the from the input the signal. Input module is automatically operate with using the on the power and the input to the program is given. Get the according to the logic. Output module is make them ready to get the output used by the contact with solenoids and contactors, alarms, etc. to automate the system, to make them to enable the system. Next things, the programming languages in PLC. The programming languages is ladder logic, LED or LD, and the next thing is structured text, and the third thing is instruction list. And fourth one is sequential function chart, and fifth one is functional block diagram. These are the programming languages used in PLC. One is ladder logic, and second one is structure test, and third one is instruction list, and fourth one is sequential function chart, and final one is functional block diagram. These are the programming languages used in PLC. And this is the ladder logic for basic gates, AND gate, OR gate. Here A also on off condition only, B also on off condition only. Here how logic will be made like in AND gate and OR gate. We will see both the conditions should be off. So totally off the system. Any one condition is off or on. Any one condition off or on. Final output anything on off or on also totally AND gate will be not able to work. Both two condition on only on. Otherwise if you making one condition also off or on or both the two condition also off, will get the output is off. So A signal, B signal, final output is will get the output is A as a B input and B is a input and C is the final answer is Y is. Make them to the like on off system. Both two things is only on will get output, otherwise no output. It's like a serial. Now we are going to discuss about the OR gate. If anything one condition also off, anything one condition also off or on, any one condition on, remaining both the condition is off, then final answer is on only in OR gate. Any one should work, is okay. Final output will get it in OR gate. In ON gate, both the things on only will get on. Any one no off only. Both the things will get on. Then only both the things will get on. Then AND gate will get output. On OR gate, anything one okay, it's good. Will get the output. No problem. Two things off only off in AND OR gate. This is the block diagram of PLC. Here various LED is mentioned. Here output box. here input box, output, input. This is the common things, L1 and L2. This is the PLC, programming board is given, source part is given. This is the both are LEDs, X3, Y3, inputs. This is outputs. This is a ladder logic program for start and stop of motor. Here OR gate is mentioned, and here one AND gate is combined as a serial wise. If OR gate and AND gate both work, finally we will get start and stop the motor. If anything one work also work. If anything one also off, also anything one okay, we will get output. But here this is OR gate logic. This is will get AND gate. Both the gate is on only will work. Get the output from here X2. This is the programming of PLC. This is L1 diagram. This is line 2 diagram. This is motor contactor. Here motor start, the button is pressed. The motor contactor is linked with M1, and L1, L2 is connected with line diagrams and motor steps. This is the serial circuit of programming port Y1. This is parallel is connected with line 1, and this is things is connected to L2. X1, Y1 is mentioned here. Here X2 is mixed their port, and X1, X2, this is a signal as a input. This is the output. X1, Y1. This is X1 and this is Y1. It is in the parallel direction or direction. X2, this is in another serial direction. We will get the output or not, we will see. Next things we have discussed about SCADA. What is the meaning of SCADA? Stands for Supervisory Control and Data Acquisition System. Supervisory Control and Data Acquisition System software. Supervisory Control and Data Acquisition System refers to a system that enables an electric utility to monitoring and coordinating and controlling and operate the distribution components and device in a real system made from remote locations, with acquisition of data for the analysis and planning from one central locations. Now SCADA means what? Supervisory Control and Data Acquisition System. You have to monitor and get the data. Both things we can able to do. System enable them the electrical utility to monitor, coordinate and control and operate the parameters and get the output. Advantages of using robots in industries: increasing the productivity. You are increasing the productivity. Industrial revolutions give rise to the mechanical, and which further helped in bringing cheaper, more goods. Mechanical process in factories were faster, helped in manufacturing large quantities of products. Still required skilled workers. Empowering workers are with more intricate tasks were needed, increasing the productivity. And applications, in the sense we are using robotics, involves any number of programmable machines that carrying out the task as a robots. Robot interact with the physical system, where like using sensory input to carry out the tasks. They offer more flexibility and single function machines because they are pre-programmables. Robots are commonly used for their application is lifting and material handling, building, assembling, picking and placing, and loading and unloading. These are the things involved in robotics applications. Robots what should be able to do? Lift the machine and material handling able to do it, and robot just will make them be able to do the welding process and assembling process and pick and place things and loading unloading things. These are things involved by using material handling things. To be able to do such a nice robots able to do, we can able to further, we can able to do the sensory things also no need to complete, and the same thing we can able to do the actuator process also we should be able to do in their applications. Advantages of RPA, robot programming: the free up cost, reduced cost, easily trackable, improved governance, easily scale, and better security in RPA. The system tedious work will be there, so focus their energy, and reduced cost, repetitive task will be continuously be there, so save the money on your workplace. Easily trackable. It is much simpler to set up the analytics for your boards, and it's usually for human interferences and improved governance. Both are programmed and strict follow the protocols and flag activity that follows outside of the scope your compliance and easily scalable, better security of the systems. The better avoid to many of the security issues also will be there, human users also will be there, so be avoided in the robot programmings. Here common uses of the robots automations, material handling, pick and place robots, material dispensing, material removal, palletizations and depalletizations, and welding and assembly. So these are the application of material handling and pick and place robots, material dispensing, material removal, palletizations and depalletization, welding, assembly. These are the things involved the application of robotics. Now we are going for the factory automations. Factory automations in the sense of industrial automations. Here control of machinery and process, implement across the process, autonomous systems. This is carried by the autonomous system of robots using the automation of new tools and leveraging technology. By using robotics technology also is there, computer technology also we are inbuilt. By implementing the automations, industries cannot implementing automations, industries cannot only optimize the productivity but can also reduce the cost, which also related to the employees and benefits and other associated expenses while optimizing the precision and flexibility. These are the factory automations involved. And these are the type of robots. Already we are using a lot of various type of robots, industrial robots and domestic robots, medical robots and service robots and military robots and entertainment robots and space robots and hobby and competition robots. These are the various types of robots involved in robotics. See, this is industrial robotics. They are the general purpose of programmable machines processing like certain human-like features. Most visible human-like features like these are the robotics anatomy of the system. Here pitch system, yaw system, roll system. Three things, very important things: rolling, pitching, yawing. Rolling, yawing, pitching. Roll, yaw, pitch. These are the very things to rotation and yaw control and like arm motions. Make them to make arm motions. This is the three things very involved in yaw control, pitch control, roll control. And another control is elbow extension. Elbow extensions and like bowler, how should bowl in the bowling technology should be able to do without arming technology and without the shoulders, swiving the options, swivel also is needed, and arm sweep, cricket batsman, bowler, make them to rotate like same anatomy to use in the various spots. Important parts is elbow extensions and shoulder swivel and arm sweep, roll to yaw, pitch. These are the important parts involved in the industrial robots. Like most visible human-like features, mechanical arm manipulators. They are capable to respond to the sensory inputs and communications and with other machines and able them to make decisions. These are the classification of robots. And this is the classification of robot anatomy and control movements and kinematics and energy source and authority of the body and industry and non-industry technology level based on the design and applications or job by number of degree of freedom should be used. These are the classification of the technology and based on anatomy as an arm, two arm and leg, arm, leg, face, five. As a fifth one is finger and 2 fingers, 3 fingers, 5 fingers. These are the arm based on anatomy structures will be used. And based on the control of movements, limited sequence robots from point to point robot and continuous robots. These are three types of robots in the control of movements involved. And limited sequence robots, they are given the linear directions, limitations, and mechanical stop and limit switch also involved with respect to the movements. To stop and fix point, we have to fix the point, starting point and stopping point. This is also involved. and mechanical movements, mechanical stop, how when where will you fix the time, and advantages, how cheap the limited sequence robots is 25 to 50%, and compared to others, this type of robots are used in casting and pressing and fixed movements. The robot is not sophisticated, and disadvantages, control movements are limited, use longer time for setting the machines. And next one is point to point robot. The movement of robot is on linear motions. You can stop the axis at any point through the path. At the end of the tool will be programmed at this sequence. Discrete point in this used. No control for the movement speed. Movement at different speed at different distance. So point to point robots also used. Usually used in industry environments where amount of work is will be zero and consistency between the movements at the outside of the conveyor it should be needed. And continuous control robots. We have seen the lot of various type of robots. Here 3 dimensional space is should be used, and point positions also involved, and complex workstation also is given, and speed of the movement of the system also is mentioned. There are examples of the robots is paint spraying machines and welding works and application things is involved. And based on the kinematics and coordinate of the movements, how the movement will be there. Cartesian movements and cylindrical movement and spherical movement and scalar movement and revolute movement. These are the things involved in the various type of movements in the kinematics. And based on the energy sources, various type of energy sources, how the robot classified, the electronic robot and hydraulic robot, pneumatic robot and mechanical robot. These are the various type of robots. And electrical robot, how we are able to elevate and tell the things with respect to the electrical robot. They are using the electrical energy to move the motors and DC motors, and using the avoiding the backlash or slow response, we can able to control or break the circuit in the options. They are using stepper motor also is there, and servo motor also we can able to use. In hydraulic robots, used hydraulic energy to move the actuators, and advantages is very powerful and most faster than electrical robot, and used to manipulate high speed in the range of robots using huge payload. And disadvantage or limitation is less clean, and cleanliness is the important features in assembling operations. And pneumatic robots is both electrical and hydraulic robot usually use the end of the tool from pneumatic powers, using limited for robot networks. In general, this robot more cheaper and simple, but it's quite hard to control and perform, less dynamic than operate. And these are the based on industrial and non-industrial robots used on home, school, field, persons. And the same thing, industrial robots is used in manufacturing, welding, cutting, formatting, assembling, heavy works and painting also is used. These are things involved in industrial robots and based on the movements. The industrial robots example is forging robot, assembling the installations and block rod from car park and robotic arm. And static robots, the robots are just stand at its pace, and various type of automatic controls are involved doing same work repetitionally, and it is used for to do the task, suitable task that is board in the industrial places and can be reprogrammed to do other tasks. So static robot is still robot, and dynamic robot is also movable one. These are the dynamic robots and low technology robots. This is the 3 type of robots in this dynamic robots: walking, rolling and sliding robots. Here low technology robots for using simpler jobs like machine loading and doing some sequence of operations in a particular time. The task can't be changed during the work and fixed control. The axis of movements are between the 2 or 4, and non-servo control robots are also used. This axis of motion is generally up and down and reaching, take the gripper to take the things you can be able to do. Here maximum it is 3 to 13.6 kilogram and accuracy is 0.05 to 0.024 millimeters. And medium technology robots and based on authority of body. The primarily you are using the robot is picking and placing the robots and loading and unloading operations. You can use 68 to 150 kg. We can able to do the payload range. And based on the authority body, in Japan Industrial Robots Associations divided into 6 class, and Robotics Institute of America is divided into 4 class, Association of Francis di Robotico make them to 4 classes in based on authority of body. The cyclic time of axis reached to 25 to 65 centimeters in 1 second to execute, and comparison of payload with respect to the robotics. Payload in low technology robot is used 3 to 4.5 kg, and medium technology is used 22 to 56 kg, and high technology used 3 to 80 kg. 3 to 4.5 pneumatic, 35 to 56 in hydraulic, and 3 to 80 electric and hydraulic used. And high technology robots is used MTR system, and using for painting, sealing, spot welding, arc welding, we can able to do lot of things involve the motions involvement, and 68 to 150 kg, 1 to 0.4 mm. These are things involved in high technology robots. These are the robotic components, manipulators and rovers, and end effectors. Robotic components, first one is manipulators and end effectors and actuators and controllers and processors and software. These are the things involved the total components of manipulators and rovers and end effector, actuator, sensor, controller, processor and software. These are the main components of robots. Basic, the robotic components examples, manipulator means main body, links and joints etc. End effector is welding torch and paint spray and gun etc. We can able to do the lot of operations. And actuator we can able to do the servo motors and stepper motors and cylindrical also you can use. And sensors used for vision and touch and speech, synthesizes things etc. And controller receive the data from personal computers and control the actuators, and processors also calculate the motions of joints and speed, and softwares using OS and application of softwares. This is the area of task, robotics task, dirty task, repetitive, dangerous task, impossible task, robot assisting the physically challenged people, space robotics, underwater robotics, and nuclear science and biomedical equipments. These are the things area is involved. These are the diagram is medical robot. How people help for this? The application of the robot is done by capturing the diagram, and the images is showing the from doctors analyzes the things how the medical by in teeth how what is happening in this is capturing the system, and the robot is able to do the process, and here medical scanning is done, and medical doctor advise what are the things you should be able to do easily useful for us. Artificial robots is usually for the medical doctors. And same thing, this is the industrial robots how using for the automations and material handling and planning and welding operations, how they are using as well as the industrial operations. And robot versus humans and manipulations, vision, smell, taste, feel, communication, thinking capacity, how arm and fingers are used for motions are humans and robots. And eyes, here cameras, nose, here research in progress, and tongues are research in progress, skin, tactile sensors, nerves, wires, fiber optics and radio, brain, computers and microprocessors, arm and fingers, motors and other forms of actuators they are used. These are the sensors, how we will be able to sense the things, sensing different form of light, sound, heat, chemical, force, object proximity, and physical orientation, position, magnetic, electronic fields and resistance of the system. Sensors how used. The sensors provides awareness of the environment by sensing the things. Sensors are the core of the robotics system that alert the robots. And the end effector, actuator's position, how will the representation of the diagram. Like end effector is the device, the end of the robotic arm designed to interact with environments. End effectors may consist of a gripper or a tool. The gripper is used for 2 fingers and 3 fingers and even 5 fingers. Actuators are also used for locomotions and manipulations. These are the actuators involved. And actuators, manipulators and degree of freedom, independently controllable components and of motions, and convenient method to allow the full movement in 3D, and grippers are also used in the things. Next, controller, the provider necessary intelligence are to control the manipulator or mobile robots. And here hydraulic motors, pneumatic cylinders, stepper motors and servo motors and DC motors, pneumatic cylinders also given in this diagram. And here controller is how it is able to control is given. These are the actuators optical sensor, tactile sensors, gyroscope and pressure sensor involved, gear DC motors and servo motors, stepped motors and engines is given. These are the relay of the system, how will work, base and iron rod and coil of the system and load applied, how will this stirrup will move and the actuator will move according to the position will operate the system. And motor drive, this is a circuit diagram, how will work by using PLC. This is both first output high, second output low, motor forward, first output low, second output high, motor reverse. This both input low, motor halt, both input high, motor halt. These are things involved in the bridge. Microcontroller, brain of robot, it implement the logic control system and servers use. These are the family of microcontroller. Thank you. These are the things we have discussed in industrial automation and control system. Thank you.